We're doing exercise 5D, and in this video I'll be answering question 3E, which says, for each of the following, find the implied domain and the corresponding range for the function defined by the rule y equals 1 over the square root of x. Now, if you're struggling with this question, I imagine it's because you don't know how to graph 1 over the square root of x. So let's remind ourselves what we can do. What we can do is graph y equals 1 over x. We know what that's going to look like. It's going to be here, and it's going to be here as well. But now, what's going to happen when I put a square root here? Well, what do we know about square roots? We know that you cannot square root a negative number. So that means that right here, x cannot be a negative number, which means when we come to our graph, this is going to go away because I can't square root a negative number, which means what I'm left with is just this part right here. So now when it comes time to writing down what my domain will be, it will be from 0 to infinity, not including 0. And that's because I'm approaching my asymptote, but I'm never going to reach it. And it will be to infinity. The back of the book writes this differently. It writes it as all real positive numbers, and that's just the same thing. And when it comes time to find my range will be likewise 0 to infinity, which is just all my real positive numbers. And again, that's because I'm never reaching 0, I'm just approaching it, and I'm going all the way up to infinity. So that's how you answer it. Question 3E. But now I just want to spend some more time thinking about this question, and I want to go to Desmos. And let's think about what y equals 1 over x looks like. We know it's going to look like this. It's going to exist in both my first and my third quadrant, and that's because I can put negative numbers into it. But then, when I have a square root of x, I no longer can put negative x values in, so that means it's only going to exist in my first quadrant. Let's also consider the fact that another way of writing the square root is like this. So this is the same thing as this. As you can see, they're the same. And that's just because we don't normally put a 2 there. We just know that when it doesn't have a number there, it means the square root, but we can put a 2 there if we wish. So what happens now that instead of square rooting it, what if I were to cube root it? And as you can see, now it exists again in both my first and my third quadrant. And that's because you can cube root a negative number. What would happen now is instead of going a cube root, I went a fourth root. So I get rid of that 3 and I put a 4 there. Well, as you can see, it's only now going to exist in my first quadrant again. Well, what if instead of going a fourth root, we did a fifth root? And as you can see, now it exists in both. And then we could keep on going, and hopefully you could start to see a pattern. So when I have an even number, it's going to only exist in my first quadrant. I can only put in positive x values. I can't put in negative. And when it's an odd number, I can put in both positive and negatives, and therefore it will exist in both my first and my third quadrant. So again, if it's even, it only exists in my first quadrant, but if it's odd, it exists in both my first and my third. And that's because when I have an odd number, it does mean that I can root it. Hopefully that makes sense to you, and just going forward enables you to understand what graphs look like. So all of that just to answer 3E. So the main takeaway is that if you can do 3E, you're golden.